I got a mandarin orange of victory.
They're all gonna be like, they started off.
You gotta let them listen to that.
Hey,
All right.
that's a rock pencil.
Can I go to my locker before we start?
Gracie needs a pencil.
You're on the air.
Oh, we're on the air. Yeah.
Ow!
People are going to know you're asking in the locker. This is published on the World Wide Web.
Oh, jeez.
What?
It is. Make sure.
Yes, Braden. It is.
Come kill me.
Okay.
Can I still go to my locker?
I got one.
Never mind.
Okay, here we go. Explain your reasoning. Tell me if point P lies on the bisector of RF. Perpendicular bisector.
Yes.
Well, it's perpendicular. It has equidistance to the endpoints. So yes, it does. Here, we're perpendicular. We have equidistance to the endpoints. So yes, the perpendicular bisector theorem says it has to lie on the line that is perpendicular and equidistance from every point on that line, equidistance to the endpoints of that segment.
That one's no.
Now, this one's asking about an angle bisector. Does DPE bisect angle DEF? And we know it does because it is equidistant to the sides of the angle when it hits it at a perpendicular angle.
So yes.
Yes. Every point lies on the interior and is equidistant to the sides of the angle is an angle bisector. And to be equidistant, it has to hit it at a 90-degree angle. So that is also a yes.
Dang, we're humming through these.
Find the indicated measure, explain your reasoning, AD.
Yes.
So, since this is equal measurements, and this is perpendicular, then this must be congruent. So AD also must be 20, yes. These aren't hard. This section and this chapter is going to be more just finding a number answer. And so far, the hardest thing in this section is finding the perpendicular bisector equation. Okay, GH. GH. Well, since these are equal distance right here, and this is hitting at a perpendicular angle,
4x plus 5 equals
2x plus 11.
Number 4?
yes. 5.
number 5. We're going to set these two equal to each other. So we have 2x equals 6. So x must equal 3. So don't stop there. It wants to know GJ. So plug 3 in. 2 times 3 is 6 plus 11. 17, yes. Notice they didn't put a bar above that because they're talking about distance. They didn't put a bar above it like that. Distance, just 2 points.
14.
Oh. PQ?
Yep.
Yes, 14. Equidistant. DGF? DGF. Equidistance to the sides, so these must be congruent angles.
3x plus
3x
8
plus
equals
8.
5x plus 12.
So 2x minus 12 equals 8. So 2x equals 20. So x must equal 10. So DGF B, G, F. I got X is 10, I got 50 minus 12 is 38.
Plus
76. If I plug it in there, I'll get 38 also. Because those are congruent, I just have to plug it into 1.
Is that 38 times 2? I'm totally missed what just happened.
Yeah.
Okay.
Yeah.
Wait, so 76 is the answer?
Yeah, because I plugged in my 10, and I got 38 right here, and this is also 38. So I wanted to know the measurement of the whole angle.
You just said a bad word, guys. I don't hear it. Just sitting on this.
Write an equation of the perpendicular bisector of the segment with the endpoints. I love these.
So these are his favorite problems.
So are these ones your favorite, Mr. Barrow?
In this section, they are. I'm going to be perpendicular to this line. This line is -2, -2, line segment, and 6, 0. I want to be perpendicular to it and go through the midpoint. So I want to be perpendicular and go through the midpoint. So I'm going to need two things. I'm going to need my midpoint, and then I'm going to write the equation using that midpoint of a perpendicular line through there. So I'm going to need to find the slope of that line. No. So first thing I'm going to do is find my midpoint. So I've got -2 plus 6 divided by 2, that's my x. My y is -2 plus 0 divided by 2. So I've got 4 divided by 2 and -2 divided by 2. So my midpoint is 2, -1. Now I know you could do a lot of this in your head, but I learned in college on my own that if I write every step out, it's a lot easier to push my pencil than it is to hold stuff in my mind. Just making work, showing every step. Plus you get credit for showing all your work, so in this case it works out good. So I got the midpoint. Now I need the slope of this line segment. I need its slope because I'm going to be perpendicular to it. So I'm going to find the slope. Difference of the y's, -2 minus 0 over the difference of the x's, -2 minus 6. I've got -2 over -8. So my slope is 1 over 4, positive 1/4. So to find the slope of the perpendicular line, I'm going to simply flip this over and change the sign. So it's going to be a -4. I'm going to flip it over and change the sign. So it's a negative reciprocal of the slope. So my slope is -4, and this is my point. So now I just use y equals mx plus b. Y is -1 equals m, which is -4, times x, which is 2, plus b. So -1 equals -8 plus b. So b must equal what? 7. So y equals -4x plus 7.
Damn.
Dang.
If we have time, we'll graph that, and we'll see that the segment here has a midpoint going through at 90 degrees with that line. If we have time, we'll try that.
Was that just problem 9?
We only have, yeah.
That was 8.
That just shows the importance of.
You ready to erase?
Yeah.
Very curious.
So
Tracy
Sounds
can
like
say
a
a
deal.
lot of things.
I'm just gonna let Mr. Dejmal straighten the work and I just go, pow, pow.
Alright, number 9. Explain how to use a perpendicular bisector of a segment to draw an isosceles triangle. Well, we just talked about the perpendicular bisector is equal distance from the end. So you take any point on that perpendicular bisector, it's equal distance to the end points of that segment. So it's going to be an isosceles triangle. So however you want to write that out in English. Any point on the perpendicular bisector is equidistant to the endpoints of that segment. So it's naturally going to form an isosceles triangle.
Mr. Daniel,
Yeah?
point on the perpendicular bisector what?
Any point on the perpendicular bisector is equidistant to the endpoints of the segment.
Yes. Grade has to go to that.
I'm afraid to say so.
Number 10.
Brayden has to go potty.
Guys. Seriously.
No, seriously, he does.
I was just saying.
In a right triangle, is it possible for the bisector of a right angle to be the same line as the perpendicular bisector of the hypotenuse? Explain your reasoning, draw a picture. If you have a right triangle with the vertex at the origin, and if the legs of the right triangle are the same length, then the perpendicular bisector of the hypotenuse is the angle bisector. And that's what it's wanting to know. Draw a line that's a perpendicular bisector of the hypotenuse that can be the bisector of the right angle. And this would definitely be. The slope of this is going to be -1. The slope of this is going to be +1. So they're going to have opposite slopes. And it's going to intercept it as a perpendicular bisector of the hypotenuse.
So if we just draw that, will that be our
That'd be enough. Yeah.
answer?
Yeah.
Alright.
You could call this 0A and this A0. That way we know that it's going the same distance.
A0 and 0A.
Yeah, 0 on the X, A on the Y, A on the X, 0 on the Y. Any letter you use, as long as you use the same letter.
See that, Joe? And what am I doing this in the line?
Point P lies on the perpendicular bisector of RF. Explain your reasoning. Tell whether.
No.
No. Why? That's right. You don't know that this is perpendicular.
I'm sorry.
So we can't say P lies on the perpendicular bisector. It's bisecting it into 2 equal parts, but we don't know it's perpendicular. We don't know these lengths either.
So now?
We wouldn't need these 2 lengths here if we had this as perpendicular. Then we'd know it's on a perpendicular bisector because it is bisecting it. Okay, explain your reasoning. Does P lie on the perpendicular, on the angle bisector of FED?
Yeah.
Yes. Good.
Did we need to
Oh,
write yes
no,
for
we don't know this.
Do we need to write yes for the other one?
Yes, that's a no. because we don't know that it's perpendicular. This can't be a yes. Why?
Because we don't know if they are the same length.
You know.
That's right.
Yeah, the angles of E are the same.
We don't know the lengths of those.
Like, I don't know how to explain it.
That's fine. You can just put question marks on the lengths.
Okay. I'm gonna do that. The other one is complex as me.
Does P lie on the perpendicular bisector of DEF? On the, not the perpendicular bisector, but the angle bisector of DEF.
Yeah, no, it is. Because it does, it shows angles everywhere.
Good. Now, it shows these as congruent, but it doesn't show these as congruent. So, this distance here is not going to guarantee that this distance is the same here. So I believe this one
No,
would
it
be
has
a
to be.
no.
Yeah, boom. Because it shows that that DE and the EF are congruent and it has a right angle on the F and D. So
These
the
on the
other
other
ones
side,
have to
this
be
needs to be the other one.
to make it 180. Boom. Cold.
Hey.
Right angle's not on the right side. So
What
it
does
doesn't
this-
tell you.
Well, we would have angle, side. Well, we don't know that we have angle though.
I don't know for sure.
We have side, side, but we don't have another side. I can't see that we can prove these two triangles, 1 and 2, congruent by any of our congruence theorems.
Common sense.
Because we have angle, side, side, but that's not a theorem. So other than that, I can't find 2 angles or 3 sides. Or a side, angle, side. So I'm going to say no on that one.
Yeah, that's what I was thinking. The ones like
We were all thinking the same.
All right. Explain your reasoning. Find the indicated measure.
Negative x plus 25 equals 6x
Good.
plus
T.
4 minus 4.
Burger.
Is that a negative 49?
Yeah.
Okay.
Mr. Daniel, when did you turn it to 5x?
I brought this 6x over, so it was negative when I brought it over and joined this negative x. So find the indicated measure AC. AC.
7 plus 25, 32.
Negative 7 plus 25.
Negative.
Okay,
18.
so 18, yeah.
So that's 18 at
That's
1 and
22.
no. It's negative though. See, I've got to plug in a positive 7. When I put it in there for x, I got a negative out front.
It is 22. Negative 7 plus 25.
No, it's, wait.
Negative 7 plus 25 is 18.
Yeah.
Yeah.
18. Good.
That's what I said. It was
You're on
18.
the air with that comment. Very good. That was Lewis,
Yeah.
by the way.
That
Yeah,
was
so
Louis.
they do it. Phone pretty stupid.
Louis
I was
Ford.
rude.
You're gonna go to jail.
So 36 must be the distance from A to C. L and M. Yes? I don't have one anymore. I ran out. People don't return them and I forgot to get more.
They're okay.
Yeah. Measure of angle L and M. Since this is 90, these must be 45s because the slope of this, you can count the slope, rise over run. This has a negative, this is a positive 1, this is a negative 1 slope. So these are perpendicular. Since they're perpendicular, these must be 45. So L and M must be 45 degrees. We kind of sped through that one.
Let's get to the 45.
Well, I just took this right here and then power squared. The square root of 2 is 1.14.
And 5 is 90 degrees.
And
I got it.
sine of 45 degrees is square root of 2 over 2.
Yep.
So that must be 45 degrees.
Good job.
Yeah. I got it.
Okay. UTW. UTW. Since these are congruent, we know it's an angle bisector, so we know this angle is congruent to this angle, so we can set them equal to each other. 2x plus 3 equals 5x minus 24. Then we simply solve for x again. We get negative 3x equals negative 27.
X equals 9.
X equals 9.
Actually.
Plug it in. 9 times 2 is 18 plus 3 is 21 times 2 is 42. So this must be 42 degrees.
42 degrees, yeah?
Yeah.
40 degrees.
Fahrenheit.
420.
Okay, here's another one of my favorites.
Oh, yeah.
Before we do it, let's finish these other two.
Alright.
So we can end with this one.
Save the best for last.
Yeah. In the figure, line M is the perpendicular bisector of PR. PR. M is the perpendicular bisector. Is point Q on line M? Is point Q on line M?
Well,
Yeah.
We don't know that.
We do not know.
We do not know.
It means it extends.
It means it extends, but you have no idea if it extends past, to the left, to the right, or in the center of the pool.
Right. Well, we don't know. We know it's not because this distance is 13 and this distance is 12. Since this is a perpendicular bisector, point Q is going to be on this side of line M. On this side of it.
that's what I'm saying.
Because that's 13, this is only 12. How about point S?
Point S is gonna be on top of the line.
Since they're both 10, point S is going to lie on the line. That's correct. So point S, yes. So Q, no. S, yes. And we don't need to do this one.
Yeah.
Okay.
Well, that's a good one.
Oh,
cross it out. Come on,
Oh,
cross it out.
I just crossed it out.
We'll do this one, see if we have time for that one.
Okay.
Why don't you try this one and go as far as you can and then check your work against mine.
Will do. Alright, so -1.
You gotta find the slope, you're gonna find the midpoint.
It's gonna end.
Find the slope and the midpoint.
Okay, first you gotta find midpoint.
Yeah.
So 3
Oh.
plus -1 over 2. And 7 plus -5 over 2. And you get 2 over 2. And I'm not for sure.
1 and -1.
2 over 2 again.
No, it's negative. On mine.
And then you get 1 and 1.
Okay, you guys work on your own. Try to find the slope and just check your work against mine.
I'm sure how to find this one, to be honest. We did it.
I will.
Yeah, you do.
Fine.
Just put wood in the fire. Don't start.
Oh, yeah, that's right.
Half the wood's there.
I'll over here, I'll tell you.
So now you're going to have 3 minus -1. over 7 minus -5. 7 minus -5. 2, 3,
What's the slope of the perpendicular line going to be to this segment?
3 minus -1 over 7 minus
It's gonna be
-5.
6.
No? Nobody said it yet.
What's third?
This is the slope of this.
Yeah.
So I want to be perpendicular to that.
3 over 4. 3.
So I flip it over and I change the sign.
Oh, -3 is negative next.
-3. Yes.
Never mind.
So now you're ready to write your equation, y equal mx plus b. Plug it in. 1 equals
Okay.
times 1 plus b. 1 equals -3 plus b equals 4. So y equals -3x plus 4.
He was laughing, so it was like,
Mr. Dejmal, I had that right.
Good. Okay.
So did I.
Me, my one's in there really not.
We got 4 minutes. Let's do this one right here. If you want to place a fountain the same distance from each side, describe a way to locate the fountain using angle bisectors. If you use the angle bisector of each angle, so that it divides each angle into 2 equal parts, the angle bisector, then where those angle bisectors intersect, it's called a point of concurrency, which we'll study in the next section. But where those angle bisectors intersect will be equidistant from the sides of the triangle.
So what's the answer?
It's right there. I have to go back.
Oh, you just draw
I
it?
want most of it.
Put a big black dot on it. Oh, okay.
hey, you're eraser.
It's a fountain.
Get into it.
They're lily pads, not trees.
Really bad.
What's you draw?
It's a fountain.
It's pretty.
Oh. I'm going to shut this off already.